In Chapter 6, we will look at how to access Linux remotely. We will use this for the midterm and final. We'll need to get the IP address using the command ip-address or ifconfig. We'll need to grab a remote access client for SSH called putty. We'll also examine viewing log files and examining modules and drivers for the Linux operating system. First, I will get the IP address of the Linux machine. I've already logged in as root, and I can use the IP address command. I can also abbreviate it IP-addr and press enter. I want to look for my Ethernet 0 adapter and record the address. Here I found Ethernet 0. I look on the third line and I find the iNet or IP address. I'll record that down so I can use it later. Your IP will be different. I could alternatively have used the ifconfig command. As you see here, the Ether 0 and the iNet address are the same. Now I'll need to go and download a client for my Windows. In your course shell, under week 6, under resources, I provided a link to take you directly to the putty download. You'll want to grab the 64-bit MSI installer. As of this recording, it is the first download link. After the download has completed, open the file and proceed through the installation dialog. Once the installation is complete, let's test our remote access. Use the Windows search feature and find putty. Launch the application. Enter the IP address you recorded. Verify that SSH is the connection type and that port 22 is selected. Click Open. Accept the security alert. Log in with root. Here we have successfully remote accessed our Linux machine. Typically, your Linux machine would be in the cloud or in some other building, and you would be using putty to access and run commands. I will minimize my other screens. I can adjust the window. I will proceed into Project 6-1. The first command, checking out what is in the var log anaconda directory. Anaconda is the installation program when you first install a Red Hat based operating system. There are several files in here. Notice the first log file is anaconda.log. Let's use the less command to view. You may want to use your tab complete to complete the directory path, and file name. So I can briefly examine this file using my up and down arrow keys. If you'll notice, we have a status column, information, warning, debug information in the list, and every step of the way what happened during installation. You may use Q to quit. I'll examine the log a little bit further. I'll use the egrep command with -I to ignore a case. Double quotation mark, open parentheses. I want to check for error messages. Or warning messages. So as I viewed the file, I seen the error and warnings were a 3-digit code. End it with a closing parentheses, double quote, followed by the path name again for the log file. egrep is able to use a pattern matching and find all of the errors and warnings. In this case, I have one error and several warnings. Your screen may be different. Let's try another log in the same folder. This log is called Journal. I've examined this previously and seen the error messages are spelled out instead of abbreviated. I'm going to modify what's in the parentheses to error and warning. I'll press enter, and this will search through and display all of the error and warning text. Using these type of search techniques will help you if you are having trouble with a Linux system. Maybe a particular process, a web server, or something is not operating correctly. You can search for warnings and errors in the log file to help point you in the right direction. Let's continue on and look at what is loaded into memory. We'll use our list command with the -F and look at the process directory. This is all of the hardware and loaded software information about the system. Notice there is a CPU info file. Let's use the less command and examine the CPU info file. As you're doing this lab, you may want to pause and just look at some of the other files in here and their contents. After you've looked at your CPU, use Q to quit. Next, let's move on to LSHW. We're going to pipe it to a less command. So we're going to look at the hardware information, listing all hardware information. Pressing enter. You can use the up-down arrow key to view information about the hardware inside of your virtual machine, or a physical machine if Linux is installed. Once you're done scrolling and looking at the information, you may use Q to quit the less command. You may want to look at page 317 in your book to look at other commands for viewing hardware information on your Linux system. We'll continue on with the lab and look at the modules, or basically drivers that are loaded into the Linux kernel. I'll again pipe it to the less command and press enter. Here I can scroll up and down and look at all of the modules that the operating system has loaded. Do you see any modules that possibly match the hardware that you issued in step 5. Use Q once you are done examining. Let's investigate an installed module. Mod info dummy and press enter. Again, you may scroll up and down inside of putty to view the entire contents, or we could have piped it to less as we did in the previous 2 commands to allow for scrolling. This is a dummy driver for testing purposes. Let's see if we can load the module into memory. Mod probe, followed by the module. We get a prompt returned. That normally means the command run correctly. Mod probe scans the module, scans the hardware in the system, and attempts to load the module and connect it to the right hardware for operation. In this case, the dummy module will load no matter what. lsmod pipe less. Do we see the dummy module loaded? Once you find it, use Q to quit. You can use rmmod to remove a loaded module. Again, I can hit my up arrow key to bring back lsmod pipe less and view to verify that the module is no longer loaded. Simple commands that you need to know for the Linux Plus for loading and unloading drivers in the Linux system. The lab takes us on to investigate setting a module to automatically load every time the system boots. Let's examine a particular directory called modprobe.d. It's located in the etc folder. Here we have a list of configurations for preloaded modules. Let's edit a new file in a different folder. Use the Vim editor. Use etc. Type in modules load.d. We'll be creating a new file called modules.config. Lit I for insert. Type in the module name, dummy. Save your configuration. Now we will reboot. Your connection will close. We'll hit OK. We will wait about 60 seconds. I've waited the 60 seconds. You'll have to pause your video and then restart. After your wait, use the icon in the upper left of putty and tell it to restart the session. We'll get the login prompt again because we've reconnected to the same IP address after the reboot. If it did not reconnect, you may have to wait a little longer and then reinitiate the session. After logging back in, we'll list modules, pipe it to less, and examine did the dummy module load. You may have to scroll up and down and look for it. Here, I found it. A faster way, with the less command and the colon at the bottom already showing, just putting / dummy and pressing enter will quickly jump you to what you're searching for. I can use Q to quit the less utility. Next, let's type DMESG pipe less and press enter. This command shows what happens during the last boot of the Linux system. It is definitely a command that will be asked, or most likely asked, on the Linux Plus certification. You can again use your / and search for any such thing that you need. In my case, I'll search for dummy. And you can use your N and P keys to go next or previous. Once you're done looking, you can use Q. One more type of command, journal. Journal CTL -K pipe less and press enter. The journal command has many options that you can specify. The -K that we used will show all kernel messages that are being sent. We'll hit Q once you're done viewing. One thing about the journal, it only shows messages that have happened since the last boot of the operating system. Let's check out another file using the concatenate command. Inside the log directory, boot.log will show us all the messages that happened during startup. You may see these scroll past very quickly when the system is booting and wish to know what happened. They are stored in a log file for you to easily view. Once you're done viewing, use Q to quit. Let's use journal again with -B pipeless to look at the logs that happened during boot time. You can space through and see all of the logs that were entered while the system was booting. Once you're done looking, use Q. Take a screenshot and submit for this assignment.